What if the one fasting length where scientists have actually caught your cells shifting into deep clean mode costs nothing, just water and 24 hours? Not a supplement, not a peptide. In 2016, researchers pulled blood from volunteers who had fasted for about a day, and inside one specific immune cell, the neutrophil, the active autophagy marker climbed above baseline. Not at 12 hours, not at 16, at around 24. That's still the cleanest single fast where anyone has caught the switch flipping inside a real human being, and there is no equivalent measurement at all for the daily 16 to 8 window most people are actually doing. So the usable answer is already on the table. If you want the fasting length with the strongest human evidence for autophagy, it's about a day, done as a habit, and it costs nothing. And it gets more interesting. The 2025 randomized trial that finally moved the needle on measured autophagy in people used a 20-hour fast 3 days a week, and it took 6 months of that pattern, not one heroic weekend, to reach significance. Same cheap tool, different dose, different result. Here's the thing almost nobody says out loud: autophagy is not off right now. It's running in every cell of your body as you watch this, a background housekeeping process that recycles damaged proteins and worn-out organelles. Fasting doesn't turn it on, fasting turns it up. So the real question is never has autophagy started yet. It's how much, in which tissue, and after how long. And once you frame it that way, the popular numbers start to look a lot shakier. The 16-hour figure has become gospel, but it did not come from a human autophagy study. It came from two things: the timing of glycogen depletion and the onset of ketosis, and early rodent liver studies that got translated across species without checking the math. Mice have around 7 times the metabolic rate per kilogram that we do. 24 mouse hours of fasting by fuel turnover is closer to a multi-day human fast. That doesn't mean 16 hours does nothing metabolically. It means the specific claim that autophagy flips on at hour 16 in humans was extrapolated, not measured. It's a marketing shorthand that outran the data. And here's why the confusion has lasted so long. There is no wearable, no breath test, no urine strip, and no blood glucose reading that detects autophagy in a living person. If you want to actually see it, your options are a tissue biopsy, and nobody is doing a brain biopsy to prove that fasting boosts neuronal autophagy, or a specialized blood autophagic flux assay, where protease inhibitors are added to your sample so the recycling markers can be caught before they're chewed up. Almost nobody has this run. So when a video tells you you'll feel autophagy kick in at hour 16, that person is guessing. There is no felt sense of autophagy. You can feel hunger. You can feel the dry mouth and the headache of early ketosis. Neither of those is autophagy, which brings us back to the Pietrocola 2016 paper, because it's the one to actually know. Volunteers fasted for about 24 hours. Their circulating white blood cells were pulled, treated with those protease inhibitors, and the LC3BII marker, the signature of an active autophagosome, was measured. And only in neutrophils did the signal reliably climb, not lymphocytes, not monocytes, one specific immune cell type at roughly 24 hours in humans. That is the earliest, cleanest human measurement of fasting actually upregulating autophagy that we have. And notice what it does not say. It does not say your muscle is doing this. It does not say your brain is doing this. It says one cell type, one time point, one measurable jump. Then in 2025, a group led by Bensalem in the Journal of Physiology ran the first randomized controlled trial to actually move a human autophagy marker with a fasting pattern, and the design is worth pausing on. Participants ate 30% of their calories before noon, then fasted for the next 20 hours, 3 non-consecutive days per week. Not every day, not 5 days a week, 3. At 2 months, the autophagic flux measurement was not statistically different from standard care. At 6 months it was, same protocol, same people. The pattern needed time to work. That is a very different message from do a 72-hour water fast this weekend. It's the message that consistency over months is what actually shifted the marker. There's another finding almost nobody quotes because it's inconvenient. Chaudhary and colleagues, 2022. They looked at skeletal muscle autophagy markers in humans after a 12-hour overnight fast, the shortest end of intermittent fasting. Several markers including BECLIN1, SQSTM1, and LAMP2 went down, not up, and nobody has actually measured muscle autophagy at 16 hours in humans to know where it lands. When the same team looked at 24-hour fasting, one muscle marker rose. So the direction of change is not linear and it is not uniform across tissues. Your muscle is not your liver is not your neutrophil. A single number of hours does not have a single answer. That pulls the rug out from under the more must be better instinct too. In 2024, supervised 3-day water fasts in humans raised C-reactive protein, IL-8 and hepcidin, markers of systemic inflammation. Platelets became more activated. The narrative that a long fast is a whole-body cleanout does not survive contact with the lab data. Cellular repair pathways do turn on, so does an inflammatory stress response. Both happen at once. And past roughly 48 to 72 hours, muscle breakdown, immune stress, and refeeding syndrome risk climb steeply. Refeeding syndrome is potentially fatal. It is not a hypothetical footnote for fasts of that length. So what's the honest, usable answer? If your specific goal is measurable autophagy, not weight loss, not blood sugar, not longevity vibes, but actually turning up cellular recycling in a way that has been caught inside a human body, the strongest evidence points to something like this. One full 24-hour fast once a week, done consistently. Water and electrolytes only, sodium, potassium, magnesium. No protein shakes, leucine flips on mTOR, which is autophagy's off switch, so a fast with heavy protein defeats the pathway you're trying to activate. If you want to lean further in, the mechanistic bet the PROFASTA trial is currently testing is that glycogen-depleting exercise before the fast, 60 minutes of cycling plus sprints, gets you to the AMPK-mTOR switch faster. AMPK is the low-fuel sensor that pushes back against mTOR. One caveat, that trial's fast is about 84 hours, not 1 day. Whether that actually amplifies autophagy in real people is what the trial is measuring. When you break the fast, break it small. A modest protein and produce meal, not a starch bomb. That's what the data supports. It's free. It doesn't need a stack, a peptide, or a device. The safety layer matters. Skip extended fasting entirely if you're underweight, pregnant, nursing, and adolescent, or have a history of an eating disorder. If you're on insulin, sulfonylureas, SGLT2 inhibitors, blood pressure medication, lithium, or warfarin, talk to your doctor before extending a fast beyond your normal overnight window. Dose adjustments are often needed. Type 1 diabetes needs medical supervision, not YouTube, and a broader caveat worth sitting with, even the best answer here is deflationary. Autophagy is inferred when you fast. It is not confirmed inside your specific body without a biopsy or a specialized assay almost nobody has run. The one randomized trial that actually moved the needle took 6 months of consistency, not a heroic weekend. If you want to place a real bet, place it on the pattern you can keep, not the hours you can survive. If this cleared some noise for you, tap like and subscribe. That's the whole reason we can keep making these plain English breakdowns of what the research actually says. If today's conversation got you curious about your own cellular health, Vegetabla gives you an energy index estimated from your VO2 max, HRV, and resting heart rate, with an honest forward projection of where you're actually trending if nothing changes. See yours at vegetabla.com.